first section is adding and subtracting fractions. We'll talk about the least common denominator, LCD, and adding and subtracting rationals or fractions is what we're going to be doing. We'll start with the easy stuff and then build up to the harder stuff that factoring is involved with and all that stuff. And once we learn how to do this, we're going to use that same idea when we go to solve equations and solve inequalities. So the least common denominator really is the most important part of this. The adding and subtracting is the easy part. The least common denominator is the hard part for these things. So we're going to talk about that first, and then we'll get into the solving of equations and inequalities. And they are very similar yet different. And then that's the end of the sections. Next week we have our exam number 2 for the semester. We will do labs beforehand and answer any questions that you have. I will send you a review this week that's similar to the test with the answer key and everything, so you can get ready for that test on next Monday night. And then after that, you have the week off for the rest of next week, and then spring break is the week after that. So you really get almost 2 full weeks of no math work to do. So that'll give you a chance to breathe and catch up on other courses that you may have in a research paper or something else that you need to do for that. So take advantage of that time. And then we will come back after spring break and have 2 more exams. And then the final. Our final exam is the last week of April. I think it's April the 27th is the date. For ours, we will take it at regular time, which is 5:45 on April the 27th. Yes, that is the day of our final exam. So we got halfway through the course after next week. 2 exams down, 2 to go, and go from there. So hopefully we can ease through that. The second half is a little bit easier than the first half was. Not nearly as much factoring. The first exam 3 has a good bit of, has factoring involved, but it's not nearly as much as we've done the last 2 weeks, last week and this week. So there is still some factoring to do after spring break, but not nearly to the extent that we're doing right now. So let's get involved in least common denominator and adding, subtracting rationals or fractions. So when you're adding and subtracting fractions, the key and rule that you have to have is that both fractions have to have the same denominator. So when we do that, there are all kinds of tricks and gimmicks that teachers use to teach you how to do this. I'm going to teach you why things work that way. We want to find the least common denominator, and we want to practice doing that, because when we get a bigger polynomial in the denominator, if you just do what some people do, some people will just say, oh, 5 times 20 is 100, and I'm going to use 100 as my denominator. That gets you the right answer, but when you put a polynomial in there and you got to multiply out an x squared plus 7x minus 12 times an x squared minus 3x plus 14, that gets a really huge polynomial to deal with, and you don't want to have to work with that sort of thing. So getting the least common denominator is a very important thing. So what you want to look at when you're looking at least common denominators is exactly the same thing that we looked at when we were trying to simplify the rational expressions, and that's factors. So when we look at this one, example A is a elementary school kind of math problem, but let's think about factors that each denominator has. Doesn't really matter what's on top at this point. We're just looking at the denominators. So what do we know about the number 5? What kind of number is it? It's prime, okay? So that means it doesn't have any other factors other than 1. Well, the next thing I want to look at is the other denominator. Does it have 5 as one of its factors? Yeah, it's 5 times what? 4, okay? So since 5 is a factor of that, then that means these 2 fractions share the 5. The least common denominator would be, what's the smallest number that 5 and 20 go into? Least common multiple, least common denominator are the same thing. So the least common denominator, we know is going to have a 5 in it, and then it's going to have the 4 as well, because there's no other factor in the with 5 the smallest number that 5 and 20 both go into, well, the smallest number that 20 will go into is 20, isn't it? And then we don't need to go any bigger because 5 goes into it 4 times. So 5 times 4 is our least common denominator. We've already got that for this fraction here. So what do I need to do to this fraction to turn that into a 20? Yeah, multiply by the 4 on top and bottom. Whatever you multiply the denominator by, you're going to multiply the numerator by that same thing. So that's going to give us 12 over 20 plus 9 over 20. And I'm showing the extra step here that you add 12 plus 9, and it's all over 20, which would be 21 over 20. And we're going to leave it there. Common denominator is the name of the game. We want to get least common denominator out of that, not just common denominator. A lot of people teach, somebody said the butterfly method. I've heard it called the bow tie method for doing this, that folks will say, okay, well, you, what's it, 3 times 20 and 9 times 5, and then add those numbers together. I don't do it that way, so I don't remember that form, that little trick. But there's a little trick that some people use, either the bow tie or a butterfly method. I can't remember which one it is, but it's a gimmick, and it works great for small things. But when you get to big things, it doesn't work. All right, let's look at B. It's a little bit bigger thing. Okay, so we got 3 over 10x to the 4th, and then 15x to the 5th is the denominator over here. It doesn't matter what's on the numerator at this point. We're just getting the denominators the same. So least common denominator. Okay, let's think about the factors that are involved here. We got a factor of a 10. But what do we know makes 10 up? 5 and 2. We got a factor of 15. What do we know makes 15 up? 5 and 3. So right now we know what do they have in common as far as factors go. 5. And then this one has a 2 and this one has a 3. And then how many x's does this one have? 4, and this one has 5. So how many do they have in common? 4 of them in common. To be a least common denominator, though, we need to have all of those things there. So we have the 5, that the 10 is, y'all said was 5 times 2, and the 15 was 5 times 3. They got the 5 in common, and then you get the things that they don't share. They don't share a 2 and they don't share a 3. So those need to be in the least common denominator. Times 2 times 3. And then y'all said they shared 4 x's, but this one had 5. So the smallest amount that 5 x's will go into is 5 x's, right? So we need 5 of them in our least common denominator. When it's just a variable, you need the biggest group of them that there are. So when it's just x to the 5th and x to the 4th, we need x to the 5th. So our least common denominator, 5 times 2 times 3, would be 30 x to the 5th. The 5 was the shared factor. I'm going to use that terminology a lot. When I say shared factor, that's the piece that both of them have. Then you're looking at the pieces that they don't have that are the same. Each one of those has to have a representative in the least common denominator. And then if it's just a letter that you're multiplying by, it's not a x plus 2 or x something or minus something. We need the biggest group of those in the common denominator. Biggest number or smallest number that 10 and 15 will both go into is 30. Does that make sense? That 30 would be the smallest number. And the way we got it was shared factor and then the pieces they don't share. And so that's going to be important as we go further. So now we just need to fix these fractions to be the right thing. So how do I turn a 10x to the 4th into a 30x to the 5th? Times 3x. What do I need to multiply 2 over 15x to the 5th by to get it to be a 30x to the 5th on the bottom? Times 2 on the bottom and the top. So that gets us 9x over 30x to the 5th plus 4 over 30x to the 5th. And then we add that together. 9x and 4 are not like terms. So we just write 9x plus 4 over 30x to the 5th. And we're done. You always want to look to see if you can simplify at the end, just because that's the rule with fractions. You always try to simplify at the end. Here, we don't have a common factor between 9 and 4, so we can't factor anything out of that. So there's nothing that happens there to make that simpler or simplify that fraction. So I always try to simplify at the end if at all possible. All right, let's look at example C. Kind of a similar problem, maybe just a tad bit different. Let's get our least common denominator, and let's try to use that process of shared piece or shared factor, and then parts they don't have. Okay, so what do we know about 7? It's prime. Does that go into 14? Yeah, it's 14 is 7 times what? 2. So the shared factor is what? 7. Then we look at the pieces that they don't have in common. 2. How many x's do we need? Well, the first one has 1, the second one has 2, so we need 2 of them in the least common denominator. So x squared is going to be there. So our least common denominator is 14x squared. That's nice when that happens, because look at the second fraction. It doesn't need anything done to it. That makes it a little easier problem. Okay, so the first fraction, what do I multiply it by to make it into a 14x squared? 2x on top and 2x on bottom. That's going to be 6x over 14x squared minus 6 over 14x squared. Those are not like terms, so I'm just going to write it 6x minus 6, 14x squared. Can I simplify that one, though? Yes. The numerator will factor with a GCF of 6. The denominator has a 14 and an x squared. What do we know about 6 and 14? They're both even, so that means they're both divisible by 2. So I'm going to simplify that to be 3x minus 1 over 7x squared. And that's my simplified version of that problem. You won't always be able to factor and simplify, but you got to keep your eye on it and look for that to be an option. It doesn't always happen, but you've got to look for it every time. It's just like with regular fractions when we're adding and subtracting those. You don't always get to simplify, but you've always got to check to see if it will. That's the rules with rational expressions when we're adding and subtracting them. You don't always get to do that, but it's got to be in the back of your mind somewhere. All right. So let's step up to binomial factors in the denominator instead of just single monomials in the denominator. All right. B. 7 over x minus 5 minus 3 over x minus 5. This one's kind of pretty. I like it. Why do I like it so much? It's already got the same denominator. When it has the same denominator already, I don't have to do any work to find that least common denominator. It's already there. So I just do the math. 7 minus 3 is 4 over x minus 5. And that's all I've got to do for that, because the denominator was already the same. They had the matching binomial factor. Show you a little bit of a tricky one here. Again, we're going to get the least common denominator. They look like they're the same, but they're not. What's the difference? Yeah, one's got a -3 and a positive x. The other one has a +3 and a negative x. So those are not the right thing. So when I've got a binomial factor or something that's not a single term in the denominator, I think factoring the whole way. in the denominators. So if I'm going to follow my rules of factoring, what's the first thing that I've got to do before I even do GCF? Descending order. Which one of those is not in descending order? That one right there. Let's put it in descending order. If I put it in descending order, that's negative x plus 3. That says the same thing. It's just in the right order now. Now, here's the tricky part. What could I factor out of this that would get it to look more like that? If I factor out a negative 1, that'll give me a plain x and change the sign to a minus 3. Now I have the factored form. So looking at the denominators, this denominator is x minus 3. This denominator is negative 1 times x minus 3. What is the shared factor between those two pieces? The x minus 3. So we got the shared factor, and then we need anybody that's not shared. What's not shared? The negative 1. So the least common denominator has got to be negative 1 times x minus 3. Which one of those needs something? The x minus 3 on the first fraction. That first fraction needs to be multiplied by negative 1 on top and bottom so that they have the same denominator then. So that's going to give me negative 6 over negative 1 x minus 3 plus 4 over negative 1 x minus 3. And then I just do the math. That'd be negative 2 over negative 1 x minus 3. And then can I simplify that? Yeah, it turns to a positive 2 over x minus 3. But factoring out that GCF in the denominator was the first step. Factoring the denominators is going to be where you're looking to try to get things happening with that. Okay. Let's look at example F. Let's say we had 4 over x squared plus 2x minus 15 plus 6 over x squared minus 25. Denominators is where you start. Those look like they can be done with factoring, right? We can do X method on this one. So this will give us a little bit more practice with X method. So multiplying to be negative 15, adding to be 2. Negative 5, negative 3. I can take my shortcut, positive 5 and negative 3. And then what does x squared minus 25 factor as? Yeah, it's a difference of squares. Now, least common denominator, once I get them factored, I look at the factors and say, okay, what do they have in common? X plus 5 is the shared piece. So that's automatically in the least common denominator. Then I pick up the factors that they don't have in common. What are the factors they don't have in common? Yeah, x minus 3 and x minus 5. So this one's going to have 3 factors on the denominator. The first fraction has x plus 5 and x minus 3. What does it not have? X minus 5. That's the one that's missing. So that's what I got to multiply that first one by, is x minus 5 on top and bottom. What's the second fraction missing? It's got x plus 5. It's got x minus 5. It needs an x minus 3. So I'm going to multiply it by x minus 3. So the top is going to be 4x minus 20 over x plus 5, x minus 3 minus 5 plus 6x minus 18 over x plus 5, x minus 3, x minus 5. And then I'm putting like terms together because now I've got all the denominators the same. So it's just work out the numerator parts. 4x plus 6x would be 10x. Negative 20 and negative 18 would be negative 38. And it doesn't matter what order you put these the denominator pieces in. I'm just trying to be consistent with what I wrote up here, so try not to confuse anybody. Will this factor? 10 and 38 are both even, right? If I factored a 2 out of that, would it cancel out any of the things in the bottom? No, because if I factor a 2 out of that, it's going to leave 5x minus 19, and that doesn't help me. It doesn't simplify anything, so I don't do anything. Just leave it like that. That's the answer. But shared factor, and then the factors they don't have in common. That's finding the least common denominator. Let's do another one. 7 over x squared plus 4x minus 5 plus 10 over x squared minus 1. What's the first thing I do? Yeah, factor the denominators. That's the first thing you should try to look for on any of these problems is factor the denominators. I'm going to do X method. Multiply to be negative 5 and add to be positive 4. 5 and negative 1. I can use my shortcut here. X plus 5, x minus 1. And then the second fraction is the difference of squares. X plus 1, x minus 1. When I go to do the least common denominator, again, I'm looking for what do they have in common. X minus 1. So everybody's got an x minus 1 already. Now I just need the pieces that they don't have. There's an x plus 1 on the second fraction and an x plus 5 on the first fraction. So my least common denominator's got the shared piece and then the two other factors that are there. The shared piece only shows up once. Then I go and fix the fractions. So what does the first fraction need? Multiplied by x plus 1. The second fraction needs to be multiplied by x plus 5. Good job. So the denominators, x minus 1, x plus 1, x plus 5. Top part's going to be 7x plus 7, 10x plus 50, minus 1, x plus 1, x plus 5. And then we get 17x plus 57 over x minus 1, plus 1, x plus 5. And I don't think 57 is divisible by 17. No, it doesn't go into it. And that's our finished. Getting a common denominator is key to adding and subtracting. It's also key to solving equations. This is what we're going to do next. Okay? Solving equations and adding, subtracting, same rules. We just got a little bit more to deal with. Okay, so let's hop in to section 1.6. solving rational equations. All right, so we'll just start over on our letters here. Say we had 2x minus 3 over 2 plus 5x over x plus 1 is equal to x over, let's put x over 2. All right. The difference here is that you've got 3 fractions to deal with instead of just 2. Okay? But the premise is exactly the same. You're still looking for a least common denominator. So the denominators, you need to first look to see if you can factor any of them. So 2, x plus 1, and 2. None of those can be factored. So they're in their simplest form at this point. So now I need to look and see, is there anything that happens to be shared between any of the fractions? That 2 on the third fraction and the first fraction is shared. So that's got to be part of the common denominator for sure. And then what's the other denominator that's there? X plus 1. So that's going to be my common denominator for this problem. It's 2 times x plus 1. So in order to do that, I've got to work out these fractions to get them to have that same denominator. So the first fraction has the 2 in the bottom, but it needs what? X plus 1. So I'm going to multiply by x plus 1 on bottom and top. This is where it gets a little tougher. On the 5x over x plus 1, what does that denominator need? Multiplied by 2. So I'm going to multiply the top by 2. That's pretty easy to do. I can do that one. And then on the third fraction, color back here. It was working for a second there. Let's quit. It needs the x plus 1 as well, doesn't it? Now, multiplying, once you get the denominators the same, everybody has a denominator of 2 times x plus 1 now, right? Once you have the denominators the same, all you have to worry about is the numerators. The numerator equation is all that's left. That's all you have to do. That's minus 3 times x plus 1 plus 2 times 5x equals x times x plus 1. Once we get the denominators the same, forget it as far as solving that equation. What you do have to find are what's called, or what would be the restrictions on the domain. Sometimes they're called excluded values. Same thing. Restrictions on the domain, excluded values. Restrictions on the domain seems to make more sense for us in Math 110 because we've been talking about domain last week, and this week too in labs. How do you find the domain of a rational function? All right, so we took all of these rational pieces and made them all have the same denominator, which was our least common denominator. So to find the excluded values or the restrictions on the domain, where does that come from? That thing. Set that thing equal to 0 and solve it, and that gets you your restrictions on the domain or your excluded values. So we're going to find those. So 2x plus 1 equals 0. Divide by 2, x plus 1 equals 0. And so x equals negative 1. What that tells us is that x cannot be negative 1. If we get negative 1 as an answer to this equation, we throw it away. We don't use it. It's an excluded value. We call them extraneous solutions back in 100. Now remember that word, extraneous. It's an extra answer. It doesn't work for this problem. The reason it doesn't work for this problem is because it gets a 0 in the denominator. You can't have that. All right, so now we got to work out this ugly problem here. So we're going to multiply all of this stuff out. So this goes back to a lot of algebra work here. So to multiply out this first piece, 2x times x is 2x squared. 2x times 1 is 2x. And then I'm going to multiply negative 3. That'd be negative 3x minus 3. This will be 10x. This will be x squared plus x. And then I'm going to simplify any like terms on each side. So I've got 2x squared. I have a positive 2x, a negative 3x, and a positive 10x. Those three go together because they're all plain x's. So that'd be negative 1x plus 10x would be positive 9x minus 3 equals x squared plus x. Now what? This is where you got to remember a little bit from previous things that we've done with quadratic equations, because those are x squareds in that problem. How do we solve a quadratic equation? What are the rules? Well, can't get x by itself because we got x squared and plain x. So we can't get x by itself, but we can get what on one side? We'll get all our like terms on the same side, right? Which would, if we do that, that would be subtracting x squared from the 2x squared and subtracting x from the 9x. And that would leave us x squared plus 8x minus 3 equals what? 0. If everything's moved from that side, there's nothing left. It's 0. So we have 0 on that side. Then we get into our options for solving quadratic equations. Because it's quadratic, I have options of solving by factoring or quadratic formula. Complete the square is also an option, which nobody ever chooses because it takes more work. Or square roots if there's not a plain x. This one has a plain x, so square roots is out. So it's either going to be factoring or quadratic formula. If we try to do the x method of factoring on this, is there anything that multiplies to be negative 3 and adds to be 8? No, that doesn't work. So factoring is no longer an option because there's nothing that does that. So the only other option is quadratic formula. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. Remember that? That in 100. So A, B, C. That's where those numbers are coming from. So I'm going to find negative b would be negative 8 plus or minus. The discriminant inside there would be 8 squared minus 4 times 1 times negative 3 over 2 times a, which is 1. Negative 8 plus or minus the square root. 64 plus 12 is 76. And so I need to do the factor tree for 76. 2 and 38. 2 and 19. So that would be negative 8 plus or minus 2 radical 19 over 2. And I can simplify that because all three of these numbers are even, right? So that means they all divide by 2. So I'm just going to divide every one of those numbers that are outside of the radical by 2. So that's going to be negative 4 plus or minus square root of 19. Technically, it's over 1, but is either one of those negative 1? Definitely not. So I'm going to keep both of those answers. Those are the solutions to that problem. They won't always be that weird, but keep in mind, we're solving quadratics when we get there. We should already know how to do those. Quadratic formula always works. Factoring doesn't necessarily always work, even though we've been doing a whole lot of factoring this week and last week. And recently we've been doing just a ton of factoring. Keep in mind, there are other ways to solve quadratics that always work, and can kind of save you some time too. Because quadratic formula always works. I don't have to check the X method thing. I tend to lean more toward factoring because we've been doing that a lot more lately. So that's what's at the forefront of my mind. But quadratic formula is also an option. All right, let's try another one. Example B. X over x minus 5 plus 5 equals 5 over x minus 5. Let's try to be tricky on this one. How many fractions are there? Okay. Well, I see the two that are obvious, but what's this one? Yeah, don't forget it's over 1. Okay. So when I go to find the least common denominator, good news is I don't have to factor anybody because there's nothing that can be factored there. So I just got to find the least common denominator out of that. So what's the thing that's shared? X minus 5. The thing that's not shared is the 1. Does multiplying by 1 change anything? No. So I'm not going to have to go and multiply everybody by 1 because I know it's not going to change anything. So the only thing I have to fix here is the second fraction, x minus 5. I need to find my excluded values or my restrictions. Remember, it could be worded either way by just setting the common denominator equal to 0. X can't be 5. When we get an answer, if we get x equals 5, we throw it out. That means because it cannot be the answer to that. Because if it were, this would give us 5 minus 5 is 0. The only number on the planet that we cannot divide by is 0. You cannot break a candy bar into 0 pieces. You take the least common denominator, whatever you find for the LCD, set it equal to 0 and solve it. Always. Okay, so now once I've got the denominators the same, everybody has x minus 5 technically times 1 is there too, but everybody's the same. So I just looked at the numerators. X plus 5 times x minus 5 equals 5. And I write that extra step there if you want to go ahead and multiply it out. More power to you. Go for it. As I normally would. That'd be 5x minus 25 is equal to 5. And then I'm going to combine like terms. So that'd be 6x minus 25 is equal to 5. And then what do? Add 25. This one's nice. I don't have to do any factoring or anything to solve it because it doesn't have x squared in it. The only time I've got to do factoring or quadratic formula is if my problem has x squared in it. This one doesn't have that. So all I've got to do is just get x by itself. So this is 30 divided by 6. Uh-oh. What's x? But that's my restricted value. That means that answer is no good. We're going to throw it out. And since that's the only answer I got, this means that thing has no solution. There's not a number that could be put into that problem and have an answer. 1x plus 5x. Right there at that step. 1x. There's a 1 in front of that x that's understood to be there. If it helps you, put it right up there. 1x plus 5x is 6x. That's where that's coming from. Any other questions about that one? A little bit easier on the solving side of that thing, but it ended up being our excluded value. If that happens, and that's the only answer you got, then it's a no solution. Okay. Sometimes you're going to find two answers and one of them gets thrown away because it matches a restricted value. right, let's look at another one. Let's do x minus 5 over x minus 3 plus 1 over x equals negative 7 over x squared minus 3x. So can I do any factoring of the denominators here? So far, we haven't had to do that. This one looks a little different because the third fraction has x squared in it. We haven't been having that. Can that x squared minus 3x be factored in any way? It's got a GCF of an x, so we're going to pull that out. It won't be done with X method, but GCF, we got to always remember that that could be the thing. And when we do that, we see, oh, look, now we got some stuff happening there. That the least common denominator, you got an X minus 3, and this guy's got an X minus 3. So that's shared. This guy has an X, and this guy has an X. So the common denominator is just going to be X times X minus 3. Going to be the whatever this third one's denominator is, happens to be the least common denominator. So what does the first fraction need? X. So multiply top and bottom by x. Second fraction needs x minus 3. Let's get our excluded value, restricted value, same thing. How do we get that? Yeah, get the LCD equal to 0. So x parentheses x minus 3 equals 0. It's already in factored form, so that means you set each factor equal to 0. This one's done. This one's almost done. So those are the things that x cannot be. If we get 0 as an answer, we throw it away. If we get 3 as an answer, we throw it away. Okay. Now I've got all the denominators the same. So that means all I've got to work with is the numerators. Okay. So take that step, x times x plus or x minus 5 plus 1 times x minus 3. And I didn't have to multiply the third fraction by anything, so I just got the negative 7 over there. So this looks like it might be a little easier. So distribute x times x is x squared minus 5x plus 1x minus 3 equals negative 7. This one has an x squared in it. That's important. So I'm going to combine like terms. Negative 5x and positive 1x is negative 4x when you put them together. Now what do I need to do? Nope. Add 7 because it's x squared in the problem. I need to get it equal to 0. So I got to move the 7 instead of the 3. So x squared minus 4x plus 4 is equal to 0. That's the quadratic that I've got to solve. Bless you. I can either do factoring or quadratic formula for this. I don't care which way you do it. We did one with quadratic formula a while ago. This one will actually factor. So I'm going to do this one with factoring, just so that we've seen both methods. So multiply to be 4, add to be negative 4. Negative 2 and negative 2. So I can take my shortcut with my factors. X minus 2, x minus 2. I'm going to end up with the same answer twice. X minus 2 equals 0, x minus 2 equals 0. Both of them give me x equals 2. I check to make sure that does not match one of my restricted values, and it doesn't. My restricted values are 0 and 3. 2 is not a 0 and not a 3, so I'm going to keep both of those answers, and those are my solutions for this particular rational equation. Isn't this fun? It's like the worst question ever. I always expect somebody to throw a tomato at me. That's why I have a strict no tomato policy. No thanks. You got a test next week. I dare you to bring a tomato. All right, let's look at this problem. Let's say we had x over x plus 5 plus 5 over x minus 5 equals 50 over x squared minus 25. Whatever happened to 50 cents? Is he still alive? He was on top of the world for a minute. He's trying to be an actor now, isn't he? All right. Lots of fives in there. But what do we got to do first? All right. Difference of squares over there. That's nice. That works out really good for our LCD. What's our least common denominator? Yeah, x plus 5 and x minus 5, because that happens to be what the other fractions had. So that works out nice for the numerator, or on the first one, got to multiply by x minus 5. And the second one, you got to multiply by x plus 5. And the third one, we don't have to multiply by anything. That's I like it when that happens. So here we have x squared minus 5x plus 5x plus 25 equal to 50. Don't forget to do your excluded or restricted value, whichever one you want to call it. Set your LCD equal to 0 and end up setting each factor equal to 0. So if you want to take some shortcuts there, you can. -5 and +5 are our restricted values. Okay. This problem has a lot of 5s in it, so I'm thinking that might come back in there. So I've already multiplied out my numerator there. X times x minus 5 is x squared minus 5x. And then 5x times x plus 5 is 5x plus 25. And then I just brought the 50 down because I didn't have to do anything to that side. Now what? Combine like terms. So I got a 5x and a -5x in the middle there. What's going to happen to those two? Cancel out. That's beautiful. When that happens, that's less stuff to deal with. Either way would work here because you could solve by square roots or by factoring with this. It doesn't matter which way. If you do by square roots, subtracting 25, we'll do one that way since we've done the factoring and quadratic formula there. You actually have 3 options on this one, but I like doing different ways because I get bored doing it the same way all the time. So here, because that's a nice number over there, and I don't have a plain x in the problem, solving by square roots is a good option, and it's quicker. So if I take the square root of both sides, the only thing that folks tend to forget when they do that is the plus or minus in front. That's the only thing that causes issues. So x equals plus or minus 5. But what were our restricted values? -5 and +5. It ends up being both of those. So they both get thrown out so that this is no solution. All that work for no answer, but you wouldn't know that if you don't do all the work. You know that. So those restrictions are important. You've got to find those. I know on the final exam in the past, I have seen questions that only ask for the restrictions. They didn't ask you to solve it. You had to do all the long work. You just had to do the restriction on it. So those are important things. That's a big pillar in this particular thing. So solving rational equations, least common denominator, factor anything that needs factoring. And then once you get the denominators the same, the numerator is the only thing you got to worry about. Okay, that's the key. All right, let's do inequalities, and I'll show you the similarities with this. Not exactly the same, but a lot of it is. So this is chapter 1, section 7, rational inequalities. All right, first thing with rational inequalities, it's going to be different than rational equations, is we want to get everything on the same side, on one side of the inequality. The reason that we want to do that is because when we're comparing inequalities, it's much easier to compare numbers to zero than it is to compare fraction to fraction. It's quicker and easier to look at. So if I ask you which one's is 2/3 greater than 8/12, most of us can't just quickly do that. But if I ask you, is 2/3 greater than 0? That's a quick answer. That's an easy thing to do. So with inequalities, if we get everything on one side first before we do anything else, that makes the comparison at the end much easier to do. So that's our first thing that you want to do. That's the one of the main differences in inequalities compared to those equations. So with the inequalities, get everything on one side first. So let's start with an example here. It's not too difficult. Doesn't have a lot of stuff going on with it. They don't get really crazy hard with these things in 110. But just gotta do it. All right, so this one it doesn't have everything on one side. It's got a fraction on one side and a 4 on the other side. So we want to get that 4 over there to the left-hand side. So we're going to subtract 4 before we even start talking about fraction stuff. So that's going to be 6 over x minus 3 minus 4, and I'm going to write it as 4 over 1 is greater than or equal to 0 now. So you want to get your rational expression with a z and a z or inequality with a 0 on one side before you start doing the problem. In the equations, we waited until we got done with the fraction part to get 0 on one side. With inequalities, you want to do that at the beginning. Okay. All right. Once we get everything like that, it's back to the same old game. Least common denominator and restrictions and solve the equation. Okay, so we're going to find the least common denominator. This one's pretty easy. We got an x minus 3 and a 1. Well, what do they have anything in common? No. Both of them need to be x minus 3. The first one's already got that. The second one needs it. Here's the beautiful thing about getting a 0 on one side. You don't have to do anything to that side. Because no matter what you put in the bottom, if it's 0 on top, it's still 0. So that makes this a little bit easier, I think, anyway, that you only have to deal with one side of a problem. Then we're going to do a restriction. X minus 3 equals 0. X can't be 3. That's our restriction. Okay. Work this problem up. Again, same deal as with equations. The numerator is the only thing you worry about. So we got 6 minus 4 times x minus 3. And we're going to set it equal to 0. Instead of doing the inequality part, we'll come back to the inequality part. We're going to change it into an equation and find important spots so that we can do the work for the inequality part. Okay, now distribute. Or the negative 4x plus 18. And then it doesn't have an x squared, so I'm going to solve it just normally. I'm going to move the 18 over. And then divide by negative 4. And reduce that fraction. Negative 9 or positive 9 over 2 is what that would be. Now, that's not the solution. That's an important number that we have to test around. Okay? What we want to do is set up interval test. Try to write that where you can read it. Interval test. So I'm just going to draw a quick number line. And here are the things that have to go on that number line. Your restriction is one of the things that has to go on that number line. Our restriction was at 3. And our solution that we found was 9 over 2. Which one's bigger? 3 or 9 over 2? 9 over 2. So I'm going to put 3 right here and 9 over 2 right here. I don't care if your number line is lined out equally spaced or anything like that, but it just needs to be in order, smallest to biggest, okay? Because you can get easily confused if you don't put it in the right order as far as writing your solutions to this. Now, can the answer ever be 3? No. So y'all remember number line stuff. I'm going to put an open circle on that. When I solved the equation, I got 9 over 2. What did my inequality symbol have on it? It had an equal to mark on it, right? So 9 over 2 could be a solution to this. Okay, so I'm going to put a filled in dot right there. That's going to help me understand whether I use a parenthesis or brackets on my intervals when I write my answers, because I want to write my answers as intervals and as set notation. So that's going to be important. Now, here's the trick, or it's not really a trick. This is the method for finding out your solutions to this. You have 3 areas where answers could be. You have this set here that's everything that's less than 3. Then you have the set of numbers that's between 3 and 9 over 2. And then you have the set of numbers that's from 9 over 2 on up to infinity. All we need to do is check a number that's in each one of those sets. And the good thing is you can pick the number. So you can make it easy or hard on yourself. I don't care which one you want to do. I'm going to go for easy. Okay? Pick me a number that would be easy to plug into the problem that's less than 3. 0. Absolutely the best one I could have thought of. We're going to plug a 0 in. That's our test number. So I'm going to go up here to my problem where I had it greater than or equal to 0. I'm going to plug in 0 into 6 over x minus 3 minus 4, and I'm going to compare that to 0. So I went to where I had the problem, 6 over x minus 3 minus 4 greater than or equal to 0, because it's easy to work that out. What's 6 over negative 3? Negative 2. Negative 2 minus 4. Negative 6. Is negative 6 greater than or equal to 0? No. So this area is false. So that means it's not going to be the answers. Okay? So anything that's less than 3 is not an answer. That's what we found by doing that. By testing an easy number. Now, what's 9 over 2? What number is it? 4.5, 4.5. What's a number between 3 and 4.5 that would be easier to plug in than maybe some of the other numbers there? 4. So I'm going to plug 4 into this inequality and check it. Okay. My testing number is Test the number 4. So that'd be 6 over 4 minus 3 minus 4. So that'd be 6 over 1. 6 minus 4 is 2. Is 2 greater than or equal to 0? Yeah, it's true. So that area is true. So that means those are answers. Anything bigger than 3 and less than 9 over 2, right now that's the solutions. But we got one more interval to check. So we need to test the numbers that are bigger than 9 over 2. What's an easy number that's bigger than 9 over 2? 5. I'm going to pick 5 and plug it in. I'm going to test the 5. So 6 over 5 minus 3 minus 4. We want to test if that's greater than or equal to 0. So that'd be 6 over 2 minus 4. That'd be 3 minus 4. That'd be negative 1. Is negative 1 greater than or equal to 0? No, that's false. So our final answer is the interval. So here's our solution. Positive 3 with a parenthesis to 9 over 2 with a bracket. That's the bracket, the little curly brace thing. That's the set notation for this. This is the interval notation for that. If you look at our number line, that's how it reads. It's false until we get to the 3. And since it's an open circle, that's why we used a parenthesis. That's why we used a not equal to. We didn't have an equal to mark on the inequality part. It was true until we got to 9 over 2, and then it got false after that. So that's why we stopped at 9 over 2 with a bracket. And that's why we put a less than or equal to with an equal to mark on the bottom. Because 9 over 2 was a solution that worked. It is possible that you end up with true here and true here. And your interval would continue out to infinity. That's possible. That's why you got to check every interval of those. So you're setting up intervals based on your restricted value and the solutions you find when you solve the equation. Let's look at another. This is it gets a little tough seeming with this stuff. It's not, I'm not a good judge of this. I don't think it's that tough because they don't make the problems very hard. But there's a lot of steps and it's easy to get messed up on that. So we're going to do a different fraction, different inequality symbol, one number that's the same. First step, every time you have a rational inequality is to do what? Get everything to one side. So we'll move the 4. 3x plus 1 over 2x minus 3 minus 4 over 1. It's got to be less than 0. So no equal to mark on the inequality symbol this time. So that's going to come back and be a big part of this. What's our least common denominator? Yeah, because the other fraction has a 1 on the bottom. 2x minus 3 is the only thing that we have as a part of that. So our restriction, 2x minus 3 equals 0. It'd be 3 over 2. And I'm not going to put that on the number line yet because I don't know where it's going to go in comparison to the solution to the equation that we solved. I don't know that yet. We're getting close to the end, guys. I know you're getting tired. It's been a long day. I've been celebrating presidents all day. So. I'm going to need to multiply the 4 by 2x minus 3 and 2x minus 3 on the bottom times that 1. And then I'm going to then swap to the numerator equation and just solve it like it's an equation. I've got to keep in mind, though, that that does not have an equal to mark on the inequality. So when I go to set up my intervals, I got to do it a little bit different than the last problem. So here we have 3x minus or plus 1 minus 8x plus 12 equals 0. Combine like terms, negative 5x plus 13 equals 0. Subtract 13. Divide. (13/5). So when I set up my intervals, I got 3/2 and 13/5 that need to go on there. Which one goes first? Which one's bigger, 13/5 or 3/2? So 13/5 is going to go over here. 3/2 is going to go there. Now, 3/2 is the restriction. The restriction always has an open circle. The solution or solutions that you find are going to be dependent on the inequality symbol. If the inequality symbol has an equal to mark, it's going to be a filled in circle. This one doesn't have an equal to mark, so that's going to make them an open circle. So it's open circle on both of those. So that means parentheses, both directions. On all of these intervals should be parentheses only. Okay. So I need to test a number from each of those intervals out of that. So in my inequality that I've got right here, this is the inequality I'm going to test in. So 3x plus 1 over 2x minus 3 minus 4. We'll test that comparing it to 0. So 3/2 is how much? I need a number that's less than 1.5 that'd be easy to plug in. 0 would be the easiest one, I think. You could use 1 if you wanted to. It's not much different, but I think 0 is going to make things a lot easier. So I'm going to test 0. That's my number. So 3 times 0 plus 1 over 2 times 0 minus 3 minus 4. So that's going to be negative 1/3 minus 4. Negative minus a number is going to be what kind of number? Negative 1/3 minus 4. It's going to be a negative or a positive number. A negative number. It doesn't matter what negative number, but if it's a negative number, is it less than 0? Always. So that, I don't even have to know what that number is. You can use a calculator to get that number if you want, but I know that this area is true because it gave me a negative, and that's always less than 0. I don't have to work it out all the way. I'm trying to save a little bit of time. And then I know this is 1.5. 13/5 is 2.6. So I need a number for 1.5 and 2.6. 2 is the best one, I think, that we could plug in. You could pick any of those other ugly fractions or decimals that you want to put in there. That doesn't matter. Just pick a number that's between those two. So 3 times 2 plus 1 over 2 times 2 minus 3 minus 4. We're going to compare that to 0. That's going to be 6 plus 1 is 7. 6 minus 3 is 3 minus 4. Is that right? Oh, that's 4 minus 3 is 1. 7 minus 4. 7 minus 4 is 3. Is 3 less than 0? So that area is false. No answers there. Okay. Last area, y'all said this was 2.6. So what's a number bigger than 2.6? Bigger than that would be 3, hopefully. 3 times 3 plus 1 minus 4. 2 times 3, I'm out of room here on my screen. So that's going to be 9 plus 1 is 10. 2 times 3 is 6 minus 3 is 3 minus 4. 10 over 3 is 3 1/3. 3 1/3 minus 4 would be negative 2/3. Is negative 2/3 less than 0? Yes. This is true. So we got 2 areas that we have solutions in this problem. We got 2 intervals. So the first interval is everything that's less than 3 over 2. So how do we write that? Negative infinity, 3 over 2, and it's a parenthesis there because remember it had the open circle, that was our restricted value. Then we're skipping all that gap in the middle. So we're going to put a U to say we're skipping some numbers. And then where's the first place we're going to pick up for solutions? 13 over 5. So at 13 over 5, is 13 over 5 itself an answer? No, because remember our inequality did not have an equal to mark. So that's why it's an open circle on our number line there. So we're going to use a parenthesis for 13 over 5. And that one's going off into infinity. And there would be our interval notation for that. Our set notation for that's a little tougher to write. X is less than 3 over 2, or X is greater than 13 over 5. I say harder, but it's not really hard. But it has to use the word or in it. You cannot write that as a compound inequality. Either of those ways of writing that. Yes, ma'am. Did I miss subtract here? 10 thirds minus 4. 3 over 2 is the number from the number line. Up here. Those numbers are the numbers that show up in the solution. These here are the ones that are in the solutions. This was just the test that we did. That's one of the things with this is just there's a lot of steps going on there. So maybe really what I would normally do with this is I would put all this testing junk on a separate piece of paper from what I'm working so that it's just scratch work really at all. And then know that these are the only numbers that can be solutions. So the numbers on your number line are the only ones that can be solutions or part of the solutions. Okay. Process is the same no matter what. It goes through these steps. They don't get crazy hard with the fractions. They're not going to put a cubic polynomial that's this long that you've got to factor in the denominators. They're not going to do that to you. We're not trying to make this, most of us aren't going to make quantum physicists out of this. Okay? So we're not trying to get too hard with this, but just the process and the logical thinking that it takes to get there is what we're after. So things happening this week. You'll have a quiz on Canvas. Make sure you're doing those and try to not wait till Monday to do it. Helps, honestly, to at least try once before. And then if you're doing your last attempt on Monday, that's a different thing than doing both of your attempts on Monday. We'll do labs next week. I'll send out a review this week with the announcement that over exam 2's material with a key involved with that. So you'll be able to practice and get ready for your test on next Monday. We'll come in, we'll do those labs, and then we'll take our test, and then you will be essentially on spring break from Math 110 for a week and 6 days. So you guys have a good week. If you need help or have any questions,